This is lesson 7-8, day 2, multiplying binomials. We're going to multiply binomials using manipulatives and algebraically. We're also going to look at some examples where we're only going to use algebraically in order to multiply the binomials. Example number 1. Copy this to your notebook paper. We have 2n plus 1 times n plus 3. We're first going to use the distributive property. 2n times n. You may go ahead and write what that product equals, which is 2n squared. If it helps you to write what comes in color, please feel free to do so. Continue to distribute. 2n times 3 gives us 6n. 1 times n is 1n. And finally, 1 times 3 equals 3. Again, you do not have to write what came in color. The arrows and the products, if you want to go ahead and write what each product equals, you may do so. If you choose to use the arrows, draw them as you're finding the products. Do not draw all the arrows first and then work the problem. Draw the arrows as you multiply in order to find your product. We'll need to simplify our final answer by combining the like terms. 6n plus n gives us 7n. So our final answer is 2n squared plus 7n plus 3. We will now model this with algebra tiles. Set up your problem. Put the first parentheses on the left and the second parentheses on the top. Draw your mat with the algebra tiles. We have 2n plus 1 and n plus 3. We'll now multiply. 2n times n gives us 2n squared. 2n times n is the same thing as we got when we worked it algebraically, 2n squared. Now multiply 2n times 3. 2n times 3 gives us 6. Again, this is the same that we got algebraically when we worked it out using the distributive property. Next, 1 times n gives us 1n. Notice we see this in our problem from earlier when we worked it algebraically. Finally, 1 times 3 gives us 3. We again see this in our answer from earlier when using the distributive property. We can match our algebra tiles to the answer we have using the distributive property. We have 2n squared plus 7n plus 3. That will be our final answer. Example number 2. We're first going to use the distributive property to multiply. You may choose to add the opposite when working with negatives. Here I have a plus a negative 5 times a plus 2. Using the distributive property, start with a times a. A times a equals a squared. A times 2 is 2a. Negative 5 times a is negative 5a. And finally, negative 5 times 2 is negative 10. Again, remember, you do not have to draw or write what came in color. Now combine your like terms to find your final answer. A squared plus a negative 3a plus negative 10. The simplest way to write this answer is a squared minus 3a minus 10. We will now draw algebra tiles to represent this problem. Draw your mat for the algebra tiles. We have a minus 5 and a plus 2. The first parentheses needs to be on the left of your mat and the second parentheses on the top. So a times a is a squared. A times 1 is a, or you can think about it as a times 2 is 2a. A times negative 1 is negative a, or you can think about it as a times negative 5 is negative 5a. Finally, 1 times negative 1 is negative 1, or you can think about it as 2 times negative 5 is negative 10. Remember, when drawing algebra tiles on your paper, shade in the negatives. Anything you see red on the screen needs to be shaded in on your paper. Notice we have 0 pairs. A positive a cancels with a negative a to make a 0 pair. So positive 2a plus negative 2a will cancel. This will leave us with a squared plus negative 3a plus negative 10. We'll now look at multiplying binomials algebraically. You will not be required to draw these with algebra tiles. Some problems have larger numbers and make it difficult to use algebra tiles. It's not going to be possible to use algebra tiles for all problems. The length of a rectangle is 5y plus 4, with a width y minus 3. Find the area of the rectangle. You may need to copy the formula area equals length times width. It told us that the length was 5y plus 4 and the width was y minus 3. So substitute those into the area formula. So A equals 5y plus 4 times y minus 3. This will be our example number 3. Multiply using the distributive property. 5y times y is a 5y squared. 5y times negative 3, if you needed to add the opposite, feel free to do so, but always be careful to see that this is a negative 3. That gives you a negative 15y. Continue to distribute. 4 times y is 4y. And 4 times negative 3 is negative 12. Combine the like terms to find our final answer. We have 5y plus a negative 11y plus negative 12. The simplest way to write our answer is 5y minus 11y minus 12. Example number 4. Copy this to your notebook paper. We have 7g minus 5 times 7g plus 5. We're going to start with the distributive property. 7g times 7g is 49g squared. 7g times 5 is 35g. Continue to distribute. We have negative 5 times g is negative 35g. And finally, negative 5 times 5, be careful you are multiplying here, that gives us a negative 25. Notice what happens when we combine our like terms. 35g plus negative 35g cancel and gives us just our final answer as 49g squared minus 25. This is a special product we will talk about further in Lesson 7-9. Notice at the beginning we started with the same terms where one was positive and one was negative. Example number 5. We have 6m plus 1 times 6m plus 1. When we use the distributive property, start with 6m times 6m. This gives us 36m squared. 6m times 1 is 6m. 1 times 6m is 6m. And then finally 1 times 1, again you're multiplying here, gives us 1. Notice in this problem, our like terms will not cancel. That only will occur if it looks like number 4, where your terms are the same in the original problem, but one is opposite the other. Here we will combine the like terms to get 36m squared plus 12m plus 1. Always remember, when you combine your like terms, your answer should be that like term. So a 6m plus 6m gives you 12m. Example number 6. We have 4x plus 3y times 5x plus 2y. Be especially careful when using the distributive property with multiple variables. You may need to write out each individual product, what has been coming into color, and then show your products in the next line. Start with 4x times 5x. Especially because we have two variables, you may choose to now write this. However, it's still not required. 4x times 5x is 20x squared. 4x times 2y, think about 4 times 2 is 8, and then x times y is just xy. 3y times 5x, 3 times 5 is 15, and x times y, you want to write those in alphabetical order. Finally, 3y times 2y, 3 times 2 is 6, and then y times y is y squared. Be especially careful with this last term. I see many students leaving off the exponent, which causes them to miss the problem. Finally, we need to combine like terms. We have an 8xy plus 15xy. Remember, like terms have the same variable with the same exponents. So our final answer is 20x squared plus 23xy plus 6y squared. This is the correct standard form. You will not need to rearrange the terms. You start with the descending order with the powers on the alphabetical order variable first. So x comes before y alphabetically. So that's why we look at x squared and then x to the first. Then all other variables follow after. So we have the 6y squared. Example number 7. We have 5m minus 2n times 2m minus 3n. Pause the video at this time to try this one on your own. Let's see how you did. Using the distributive property, we have 5m times 2m, which is 10m squared. 5m times negative 3n is a negative 15mn. Next, we have negative 2n times 2m is negative 4mn. Finally, negative 2n times negative 3n, a negative times negative is a positive 6n squared. Did you remember to put an exponent of squared on your variable n? Finally, combine the like terms to find our final answer. We have 10m squared plus a negative 19mn plus 6n squared. Again, this is the correct standard form. M squared would go first, then an m to the first, and then all other variables follow after. So we have the n squared. Example number 8. We have y plus n times x plus a. Be especially careful with so many variables in this problem. So we have y times x. We normally write our answers in alphabetical order, so this would be xy. Next we have y times a. Again, remember alphabetical order, so we do ay. Continue to distribute. N times x gives us nx. And finally, n times a gives us an. Notice we have no like terms to combine. This would be our final answer. We will not be concerned about standard form when there's multiple variables in a problem. Example number 9. We have y plus n times x minus n. Do you think the middle terms will cancel when we get to our final answer? We'll see. Let's use the distributive property. Y times x, remember alphabetical order, y times x we will write as xy. Y times negative n is negative ny. N times x is nx. And finally, n times negative n is negative n squared. Be very careful and remember to put that exponent squared. Here we see no like terms. Our terms in the center will not cancel because from the beginning, although they were opposite binomials, where one was positive and one is negative, the terms are not the same. We have a y and an x. So our final answer here is xy plus negative ny plus nx plus negative n squared. You can simplify by writing minus instead of plus a negative. This concludes Lesson 7-8, Day 2. We have multiplied binomials using manipulatives and algebraically.